We have to find the pole location. For this given two values for overshoot, we have 12%. For settling time, we have 0.6 seconds. So, we have here the given overshoot percent of 12%, or it's equal to 0.12. So, in finding for dumping ratio, we have to use this from the equation. For overshoot, we have percent of overshoot is equal to exponent raised to dumping ratio times pi over square root of 1 minus dumping ratio squared times 100. So, this is the formula for finding the overshoot with the given inside the given value we have the dumping ratio. So in finding the dumping ratio, therefore if we use this formula, OS which is 0.12 is equal to exponent raised to negative dumping ratio times pi over square root of 1 minus dumping ratio squared times 100. So if we shift and calculate that in our calculator, we will be having dumping ratio is equal to 0.55. So this is our dumping ratio. So for TS, we have 0.6 seconds. So in finding for WN, so from the equation, 4 is equal to dumping ratio WN. So therefore, if we're going to find for WN, simply input dumping ratio, which we have 0.55 times WN. So we try to shift cal, WN would now become 12.1 rad per second. So this is our WN, and if we're going to find its dumping ratio times WN, just simply multiply 12.1 times 0.55. Then if you multiply that, you will have the answer 6.66. So in finding the pole location, we have the formula of negative dumping ratio WN plus and minus GWN times square root of 1 minus dumping ratio squared. Or this equation, we can simply dumping ratio WN plus minus GWD. So this equation is just similar. So therefore, our final answer for pole location, S is equal to our SWN, which we have 6.66 plus for GWN square root of 1 minus dumping ratio squared. If we try to input, so we have J, our WN is 12.1, then square root of 1 minus dumping ratio, which is 0.55 squared. That would that will be equal to 10.1 J. So this is the whole location for this given problem. So that's all. Thank you.